Hello, Assalamu alaikum everyone. This is Iman Saeed Dawray. I'm a second year student of Doctor of Physical Therapy. I have done my matriculation from St. Girls High School and I have done my intermediate from the School of Science, Arts and Technology. So guys, today's topic is hybridization. It's an important topic in chemical bonding. As I'm done with my brief introduction and the introduction of the hybridization, so let's move on to the topic. The first slide that I've showed you is the key points you must know before learning this topic. If you know these topics, then you can understand this topic, hybridization, completely. Otherwise, you won't be able to get a single thing in your mind if you don't know these. Firstly, you must know what are orbitals and quantum numbers and how you define them. That is, your concept must be clear according to these topics. Secondly, you must know what is valence shell and how it takes part in forming a bond. Next, you should know what are chemical bonds in detail. That is, you must know what are sigma bond and what are pi bond because there is a slight difference between them. The third thing, the last thing that you need to know is what are energy levels and sub-energy. The contents of the topic. Here's what you learn in this class. You will learn what is hybridization, who introduced it to the world of chemistry, types of hybridization, Sp2 hybridization, and Sp3 hybridization along with example for each. What is hybrid orbital model and how can we predict states with the help of hybrid orbital model? Linear molecules, planar trigonal molecules, and tetrahedral molecules in detail. Shape of water and ammonia. So shape of water and ammonia will be just a brief discussion on it so that you can get the idea of sp3 hybridization completely. What is hybridization? This is the overall history of hybridization so that you can get the idea what basically hybridization is about. In chemistry, orbital hybridization is the concept of mixing atomic orbitals into new hybrid orbitals suitable for the pairing of electrons to form chemical bonds in valence bond theory. So who introduced it? Scientist Pauling introduced the revolutionary concept of hybridization in the year of 1931. He described it as the redistribution of energy of orbitals of individual atoms to give new orbitals equivalent energy and named the process as hybridization. What is hybridization in easy words? It's the intermixing of atomic orbitals of same or nearly same energy. What is same energy and what is nearly same energy? Same energy, if the shells are arranged in the same energy level, then it's called same energy level. But in hybridization, before hybridization takes place, the atoms, the orbitals are not placed in same energy level because as there is different quantum numbers and there is different orbital numbers. So in hybridization, the nearly same energy levels changes into exactly same energy levels. When the new hybrid orbitals are formed, they are formed with the same energy levels and therefore the electrons form chemical bonds in the valence bond. Now move on to the next slide. This slide talks about what are the types of hybridization. First is sp hybridization, the second type is sp2 hybridization, and the third is sp3 hybridization. What is sp hybridization? Sp hybridization is observed when one s and one p orbital in the same main shell of an atom mix to form two new equivalent orbitals. The new orbitals formed are called sp hybridized orbitals. It forms linear molecules with an angle of 180 degrees. The thing with sp hybridization is that you can also get it by the name that sp hybridization. That is one orbital is s and the other is p. Is observed when one s and one p orbital in the same main shell of an atom mix to form two new equivalent orbitals. That is when they mix together, the s orbital and the p orbital mix together, they form two hybridized orbitals that are called sp hybridized orbitals. And when the molecules are arranged, they are arranged with the bond angle of 180 degrees. Now let's move to the example of sp hybridization. The example of sp hybridization is acetylene. Both carbons are sp hybridization. And sp hybridized in an sp hybridized carbon, the two s orbitals combine with the two px orbitals to form two sp orbitals that are oriented at an angle of 180 degrees with respect to each other. Let me explain this example. I have some pictures so that I can show you. So first I'll move to the electroconfiguration of carbon and hydrogen. As the formula of acetylene is C2H2, so we must do the electroconfiguration before moving down to the hybridization. So when we do this is the electroconfiguration of carbon in the ground state. That is 1s2, 1s, first shell of s orbital contains 2 electrons. The second shell of the s orbitals contains 2 electrons, that is it's paired. The third, uh, the second shell of p orbitals x1 contains 1 orbital, that is it's unpaired. Py also contains 1 electron, but the pz is empty. So in excited state, the 2s2 here will move on to 2pc here. So all the 4 electrons here will be unpaired. All the 4 electrons here, these 4 electrons will become unpaired. So here we will have 4 places of hybridization, but as it is sp hybridization, that is only one s orbital and the other p orbital can take part in it. So the py, 2py and 2pc won't take part in hybridization. When the hybrid orbitals are formed, the two hybrid orbitals are formed. As you can see, this is the hybrid orbital of carbon 1, and this is the hybrid orbital of carbon 2. They will make a single bond with each other. The shape will overall remain linear, but the px orbital and the p orbital and the pz orbital will just arrange themselves perpendicularly with the bond, and they will make the pi bond with them. Otherwise, if you look at the overall shape, the angle between the bond angle is 180, and this is the molecular form, the Lewis theory concept. So you can get the idea that the overall angle is 180 degrees. The shape is linear. Linear means straight.